Now we're going to get into actually calculating the formulas that we talked about in the prior presentation. All right, so before we were just talking about compounding, we were also talking about the discount rate as well as the net present value. And so the formulas that I showed you, for example, PV plus PV times R, right? It was a compounding formula. I wanted to basically show you how to do that in Excel. And all the formulas that I showed you all before, like I said, I did all of these in Excel. All right. So here, I want to illustrate how compounding really works. So imagine if someone offered you 1 cent, a penny, right? And they said, you know what? I'm going to give you a penny, and then for the next 30 days, I'm going to double the value of that penny. Okay. The question is that deal worth my time? So let me show you how compounding works, and I'm going to show you that that deal is really worth your time. So just for brevity here, I'm going to just paste the formula. Well, first of all, you see day one we have 1 cent, right, and then we employ the formula here, right, and so we anticipate to have 2 cents the next day, and as you can see on the next line, we have 2 cents. Now let's go ahead and put the formula in. Paste special formula. Okay. All right, and so now you can see that after 30 days, right, that penny has generated $10.7 million. So the moral of that story is if anyone offers you a penny and want to double it every day for the next 30 days, for the next 10 days, right, you take that deal. I mean, although it'll only be $10, but still, $10 is worth more than 1 cent, right? And you notice, right, how compounding works. When you get down to about uh, day 21, you're starting to get into some real money, $20,000. And then by day 24, you're at 167. By day 27, you're a millionaire. Okay, so again, that's a good deal to take. So now let's look at the deflation example. Now, what I have here is a table very similar to what Mike Sell presented on page 318 of chapter 7 of your textbook, where he talks about uh, discounting values over time. So now what we're going to do is instead of compounding over time to see what a current value will look like in the future, now we're going to take a future value and deflate it back to the present value. All right. So looking at this project, you can see that we have 5 years worth of information, fiscal year 1 through 5. And we also have our discount factor. And the discount factor essentially is just, again, a formula where I have 1 divided by 1 plus the rate, and my rate is 3%. Okay, so when I do that for year one, that gives me 0.971. So then I take the 0.971 and multiply it times 15,000, and that gives me a present value, a discounted value of 14,563. So next year will be fiscal year one, but the current value of next year's dollars for 15,000 is really worth 14,500. Okay, based upon this 3% rate of return. Year two, $10,000 is worth 9,400. Year three, 16,000 is worth 14,006, and then in year four, 15,000 is worth $13,300. Okay, now looking at our discount factor, right? If you notice up here, my number, my formula, you notice I have the little hat symbol and a 2. So for those of you all who aren't really familiar with Excel, if you want to take a number to the power of something, just take the number, the base number, put the hat symbol to the right of it, and then put your number that you want to take to the power of, right? So here I took this number, this formula, to the power of 2. So I have the formula, the little hat symbol, and then the power of 2, right? And then I did the same thing for the power of 3 for the third year, for the fourth year, and for the fifth year. All right. So remember in the last presentation, I talked about uh, discounting when you have a constant value. Now, one way to do this, to figure out our discounted rate based upon this constant value, would be to do the formula several times, like I did before when I had different numbers. But instead, I'm going to use my annuity formula. Now, first of all, you'll notice after I did the formula several times with $11,000 being constant, $11,000 over 5 years is projected to have a future value of $55,000. However, when we discount that, over those 5 years, that 55,000 gets reduced to 50,000. Okay, so now imagine if I had 30 or 40 years worth of data, right? And I necessarily wouldn't want to do this 30 times. So what I can do is just basically use my shortcut annuity formula, which is the PV equals S divided by R times 1 minus 1 divided by 1 plus the rate to the power of n. Okay, uh, and I click on the number here, and you can see I plug the number in up here in Excel, and you see that they came out to be the same, 50,376. 50,376. Okay, so basically, so instead of doing that number, doing this formula 5 times, I did it once using my annuity formula. All right. So now let's look at the net present value. Okay, and as I said before, the net present value is just simply a cost benefit analysis. All right, you basically what you're doing is you're weighing the costs against the benefits over time. Now, if you recall, that formula had a sigma symbol in front of it, which basically meant that we needed to do the formula several times and then add all of our products together from that formula, and that's what I did here. So my net present value came to 354,668. Now, how did I get that? Well, let's start with year one. Okay, I have a year zero here, and I'll talk about that in a moment. But let's start with year one. So my benefit was $50,000. That was given. My cost was 150. That was given. So then I deducted the cost from the benefit, which gave me a negative $100,000. Okay, and then I took my discount factor, which is based upon my 3% rate. Okay, and I divided my difference between my costs and my benefits by the discount factor to give me my net present value. Okay, and my net present value in this situation is negative 97,087. Now, and you just basically do the same thing for how many ever years that you have. All right. Now you'll notice again in my formula, as in the deflation example that I showed you all, I'm going to take my formula to the power of whatever year I'm in. So here I'm in year one, right? So I'm taking this formula to the power of one, which is cell B5 here. The next year I take it to the power of 2, which is cell B6, and so on and so forth, all the way down until I take it to the power of 30, which is why I actually numbered my years. Now, going back to time 0, anytime, and this is very important, anytime you're doing a net present value calculation, start with time 0. And your discount factor for time 0 is going to be 1, because the time, basically, the rate does not necessarily affect this time because it's not growing or deflating. It's just a constant time because that's your starting point. Okay, start with 1, and then from time 0 you will begin your next year, which is time 1. Okay, and then at time 1 you begin to do your actual formula, which is the 1 plus the rate taken to the power of whatever year you're dealing with, and you do that several times and you add it together, and that's your net present value.